There's life very different now, but the planet itself has changed. The Earth's crust is broken into huge plates like pieces of a jigsaw that jostle and slide over the face of the globe at a few centimeters a year. In 100 million years' time, the continents will be in completely different positions. But this movement is not the only reason the Earth looks so strange. Over millions of years, carbon dioxide from volcanoes has created a massive greenhouse effect, slowly warming up the planet, melting the ice caps, and causing the sea level to creep higher and higher at about 1 millimeter a year.
So at this 100 million year in the future time frame, one of the environments which we're looking at is a huge near coastal swamp. It's partially brackish or the influence of the ocean. It's got a huge amount of fresh water flowing down into it, reminiscent perhaps of some of the great coal swamps of 300 million years ago. Rich in life, teeming in a whole bunch of new adaptations. Very high moisture, high warmth, a steaming tropical jungle magnified.
It's descended from a very unexpected ancestor.
Well, the toroton that roams the Earth in 100 million years' time has evolved from today's tortoises. And you can still see the similarities. It's got a shell, albeit a much reduced shell, and a long wrinkly neck just of folded skin, and a head that's covered in scales. But there are big differences. It is big, this animal, and its legs have moved from a sideways position like this in the tortoise to underneath the actual animal to support it like 4 great big pillars as it walks along, just like an elephant's legs.
Any animal bigger than a ton has to support itself with legs directly under its body, not out to the side. Otherwise it wouldn't have the strength to stand up. Once the toroton had changed its gait to accommodate this, it could get bigger and bigger.
Along the way, it's had to adapt to a terrestrial existence and be able to actually move around and live out of the water. How does it do that? How does an octopus live out of the water? Now we know that even modern-day octopuses can do that. If you've ever seen one escaping from a marine tank, it'll climb up the corner and down the side and across the floor and back into the sea. So just by pulling themselves arm by arm along, we know that octopuses can deal with a terrestrial mode of locomotion. But one thing that a modern octopus can't do right now is breathe out of the water, and that's one of the major adaptations that these swamp octopuses will have had to have invented.
The youngsters of this octopus are perfectly good prey items. But by clustering them all together within what amounts to a nursery inside of this vase, the adult octopuses, which have a venomous bite, can gather around and protect the young octopi. They can bring in food to feed to them and, in a sense, keep an eye on them. You may think that we have just, in this reconstruction, invented a piece of science fiction. No, all we've done is change the players and shown you something that's going on at this very instant on this planet now. Just what's in it for the amphibious octopus, but in a coevolutionary relationship that has to work in both directions, what's in it for the plant? The plant has timed its flowering so it occurs at the same time when the octopi are nursing their young, which means that when the flower stalk emerges from the center of this large bowl, that no herbivore is going to bother it because there are the guardian octopi around the outside guarding their young. And so the process of fertilization and pollination can take place up on the top of the flower without disturbance, without anything destroying it.
Electric fish now generate voltage in small blocks, small muscle blocks along the length of the fish. Each generate a small electrical potential. And like batteries in a series, those muscle blocks along the length build up a bigger and bigger charge.
The lurkfish takes this even further. It's over 4 meters long and has huge numbers of muscle blocks packed along its body, which build up a massive electrical charge. In a matter of seconds, it generates 1,000 volts. By generating such a powerful charge, the lurkfish can stun something as big and venomous as the swampus before it has a chance to fight back.
The adults are enormous, the biggest animals that have ever walked on the face of the planet. 120 tons. That's bigger than even the biggest dinosaur. Now, there are lots of advantages about being so big.
They're far too big for swampuses to kill. Adult tauratons have no predators. But they're also big because they eat vegetation. And not only so they can reach high up into the treetops.
When you're eating all this vegetation, you need to ferment it to get all the goodness out of it. You need an enormous stomach, a big barrel-shaped stomach, and the bigger the animal is, the bigger its stomach's going to be, so it can extract all the goodness out of all the vegetation over several days. Of course, there is one major problem about being so huge, and that's when it comes to mating. Now, modern-day tortoises mate on top of each other, but of course the tauraton is far too big for that. The female will not be able to support 120 tons on her back during mating. They've solved this problem by mating back to back. They're simply backing to each other and the face away from each other during courtship and mating. During the actual mating, when they are back to back, the male and the female raise their tail to reveal the cloaca, and the two cloacas actually touch, and that's when the sperm is transferred from one to the other. That's the only physical contact they have during mating.
It takes a long time for a tauraton to grow to full size.